Good afternoon and welcome back to the TopSolid 7 update webinars. My name is Bill Gantz. I'm your sales and technical director here at TopSolid USA. I'm joined by Joe Hart, our technical manager, and Mike Kay, our sales manager. If you guys have any questions during this presentation, please be sure to type them into the system. We'll do our best to answer them as quickly as possible. All right, so this webinar is going to focus on the new improvements regarding 3D machining in TopSolid. Let's jump to it. All right, so for 3D machining this year, there's roughly 14 new improvements that are worth talking about. Let's start right away with the first one. And that has everything to do with fixture avoidance. Weird. Well, fixture avoidance is now available directly in the operations for all of the material left machining. So that's everything that's in this category here. So if you look, right now I'm in a constant Z material left. If I go to my geometry button, I can go to my fixtures tab here and notice I have my two fixtures selected. Okay, and you can see the toolpath is staying away from them. Something important to understand, you can have a specific offset for a fixture and you can have a global offset for all the other fixtures. The thing to understand is only, like if I put 2 millimeters here, I have 3 millimeters here, so this one will be taken into consideration. If this one, if I double click and set that to 1, for example, this one will not be taken into consideration. So this is the priority, and then you can set independent offsets on top of them to be greater than this offset. Okay? And again, that works in all of the residual machinings. Okay? Very nice. Next. Another improvement to residual machinings, choosing which previous operations to consider. All right, so we had this in, I think, the roughing routine, and we brought it forth into the residual machining routine. So now under geometry, you can go in here and choose which previous operations to take into consideration when calculating this rest machine. Okay, so to give you an idea, this residual machining is being done with all of the previous operations. This one is being done with all but one. So if I go in here, you can see I deselected the raster passes there. And if you look at these, and I'll look at them straight on, might be simpler to see. Look in this area here, you'll see the difference. So here, you can see the tool path is staying just inside there. And if I go down to here, you can see it overlaps a little bit more. Okay? So again, the idea here is that you have more control over the calculation of the residual machinings. All right, another lovely new improvement has to do, again, with residual machinings. We've now given you the ability to add multiple passes, okay? So if I go to my residual machining for radius machining here, and take a look, right here, you have your last pass depth, you have your main axial depth of cut, and how many passes you want to take, okay? And if I zoom up, you can see it's doing exactly that, okay? Same thing for the residual machining. All right, now here, this is doing it, even if you have it set, and this is an important thing to understand, this one is doing it only based on the material that's present, okay? So you can set the maximum depth of cut that you want, but it'll only add residual cuts or additional cuts where needed. And then on pencil machining, for example, you can see more clearly what this is actually doing. So for example, let's say I want my last pass step to be a quarter. Let's say that I want my quarter of a millimeter, pardon me, 0.025 millimeters, and I want my main axial pass steps to be 0.1, and I want 10 passes. Okay, just to see. You'll see more clearly what's going on here. Feels like I could have done 5 passes, but you know, it's all good. So here you can see those passes. You can see that last depth of cut, just like the skim pass type thing. So again, it's all there to help give you guys the ability to do stuff. Let's see, are the multi-pass is calculated normal to the surface or by some other method? Axial, radial. So it depends on the algorithm. They are calculated in 2 ways. One, like pencil machining is going, think of it as, or this, think of this as your corner, right? And it's going to be going passes like this. So it's going to be nibbling into the corner. The other machinings, they are doing it based on constant Z or constant step over. So it's using that algorithm, but then it's offsetting into step, while taking into consideration how much material is actually there. Okay? Perfect. Let's go to the next one. All right. This one we saw in end milling. Okay, but just to show you, it's available in roughing as well. So if we go to settings, it's a little bit wider so we can see, and we go to our plunge and retract, you have a custom down feed rate, you have a custom spindle rate, you can add a dwell for when the spindle rates change, and you can have custom coolant codes now as well. I think I mentioned it in 2D, but now you're seeing it in 3D. Next. This one I think is quite nice. So, planar face machining. I don't know if many of you use this command. I think it's an awesome command for dusting off all the planar faces of a part. You can now optimize the movement between faces, kind of like we have in drillings, in fact. So, if we look at these, you can see it's hopping all over the place. You now have the ability to control that sort. So, for example, I can go to shortest path, boom, and done. Okay, and now you have less time rapiding, more time machining, which is always better. Something to understand is that if we add, let me go into my settings here. If we add additional paths here, okay, so I'm going to say number of additional passes, I'm just going to say is 2, and I'm going to put it at 0.05 millimeters. We'll recalculate. The old organization of strategies, order by altitudes command, because we're optimizing the motion, goes away. Okay, so it grays out here. Should be grayed out in here if we go into here. Well, it's supposed to gray. It's supposed to gray this out, but it basically doesn't take this into consideration anymore because it's using the sorting methodology you've defined here. Okay. Perfect. Let's move on to the next one. All right, this one is, I think, maybe a little bit interesting. It can help you understand what you're looking at when it comes to using the swept machining, and more importantly, how to control the constraints around it. So, for example, let me just hide this thing because I don't want this. We'll hide this. All right, so we're sweeping this face here. If we go in and edit this face, and I go to geometry, I'm not sure how many of you know this, but if you double click here, you can play with the ISO curves to control the area that it's going to machine. Okay? So it's like doing a parametric trim of the surface, like so. That's not the improvement though. The improvement is that you can choose to show the length of the ISO curves. That's this thing right here. So this option is the improvement. It just gives you a length. It's not modifiable. You can't double click on these things. Okay? You can move them out of your way, but they will update as you move the ISO curves. Okay, so this way again, you have a better idea of the area that you're machining. Okay? Perfect. Okie doke. Next one, changing the order of passes. when we have multiple passes in sweeping. This one I think is really nice. Let's take a look at this one first. So if I rotate this to the side, you can see I have multiple passes, right? So prior to this version, you didn't have real good control over that. Now you do. So you can go up here into settings, and here you can choose to be having the pass order done axially first or radially first, okay? So right now, let's leave it on axially, and we'll go and simulate it. And you'll see, I'm just gonna speed this up, you'll see that it just does that first radial depth of cut on all passes going down in Z. You also see I'm banging into my part with my holder because it's fun, okay? And then from there, we can switch that mode to be radial instead. Slow this down. So now you've seen it's nibbling in at each, think of it as a Z level, before moving down axially, okay? Now, for those of you that are curious, of course, yes, this also works in 5-axis. So if we look at this from this side, again, you see the multiple passes. You see you still have radial axial control here. And if we simulate that, you can see that's being done with a tilt and taking everything into consideration. All right. All right, so vertical roughing. We have made a lovely optimization here. And apparently I saved the optimization. So let's go into here. And, oops, pardon me, into here. Do that. Because then I can explain the optimization better. So in vertical roughing, there was really no easy way to control that drilling over depth. Maybe we did it with extra geometry. I don't remember. Yeah, you could add an additional surface as something to stop it from going through, but you had to do manual work there. If you happen to have already roughed out this side and did a repositioning of it, it requires you to do extra work to really control the vertical roughing. So the improvement in 7.16 is right here. You can just choose optimize depth, and then it will auto-calculate the drill depths for each plunge move so that it's optimized based on the real material conditions. Okay, and if I turn that on visually so you can see the depths are changing around that sphere. Cool. All right, this next one, I think a few of our customers here in the US asked for this as well. This is a toolpath strategy, I should say, or improvement to 3D sweeping to trim the toolpath to the stock condition. To the keen observer, that might even look like a crankshaft, right? Or part of a crankshaft. Now, here's the optimization. We're going to go into our settings here. And down at the bottom here, you see trim to the stock. So let's go activate that. You can choose your clearances and your maximum for link. I'll describe what all those are. So basically, the clearance off the stock allows us to have some margin, okay? To be sure that the toolpath doesn't do a link or clearance while still in contact with the stock. Oops, it would help me to hit the green check mark. Now you can see, and then you can play with your rapids, of course. But now you can see we're trimming that toolpath to the actual stock condition. Cool. All right, constant Z. This is a little one, but it's one we got to talk about. There is a new lead-in option right here. Tangent arc alone versus tangent. What's the difference? We go back to tangent. Let this calculate. Tangent includes that little perpendicular move to the arc. Okay? And the reason we include it is because if you're going to activate 3D compensation or 5D compensation, if your machine supports it, typically you need this vector shift in order to activate the 3D compensation. And some machines you don't, but at the end of the day, we've had people request that we don't want that. We just want the tangent arc alone, so we get rid of those extra little movements in there, just to have a little bit cleaner lead in, lead out. Alrighty. This next one I'll talk about, but there's not, it's more of just a modification to the algorithm. Okay. So in the roughing algorithm, when you're integrating the outside material approach in the security distance, the safety distance movement was originally done in linear or work feed rate. This would sometimes generate some incoherent sequences of feed rates when using an outside material approach. So you might see in your approach feed rates on the outside here some changes in feed rate because of how this was being calculated. All I'm going to tell you is that in 7.16 we have made it smarter. The movement has now been set to use the same feed rate on the outside material approach to make sure that you don't have a change in feed rate during that approach. Okay, so it was something that would happen occasionally. It was an oddball thing, but we've identified and corrected that option. This correction, by the way, is valid in 3D roughing, but also in roughing finishing and planar face machining. Okay. Next, under 3D roughing, just a quick talk about final pass depths and planar face machining. So here I'm doing a boost style roughing toolpath. Okay. My altitude is I'm taking a 20 millimeter depth of cut, and then I'm doing a planar step over to machine this top face and this final planar face. And if I zoom up, you can see that the step over is greater. The improvement here is the fact that instead of it just being set to a value, you can now set it as identical to whatever your original step over is, custom, which by default is set to 70%, or as a factor. So for example, I know that if I'm using boost milling, I'm always going to be at a smaller radial engagement for the main roughing, but when I go to finish the floor, I'm not removing that much material, so, or semi-finish the floor, however you want to consider this, I want to take a much more significant step over, so I can just set a rule here of 300% or 200% or whatever makes you happy. Okay, and then if you see the tool path, you can see you got your nice big step overs where there's not a lot of material, smaller step overs where there is material, and then for that final pass, you can see just a little bit bigger. All right. Next, personally, this one was long sought after tool path optimization. What are these? So for those of you that use 3D morphing, congratulations, you're using a great 3D toolpath. For those that you don't, you should use it because it's awesome. Here's the improvement. So I'm going to start my first curve right there, and now I want to morph from here into the center, but oh man, I forgot to make a point. And in 7.15 and before, if you didn't make the point, you had to stop, kick out, go back, make that point to synchronize to. Now you have the special inputs button. You can create a point any which way you want. I'm just going to create a point and snap to the center there. Perfect. I'll add my synchronization profile right there. Hit go. And I screwed up. Good job, Bill. What did I do? Good sample. Oh, because I have to pick a tool. Sorry. There we go. So the improvement is you can pick the point on the fly. And as you can see by the tool path, it's a nice, smooth tool path blending into that center point. Okay? And then finally, this last one is pretty awesome. It's an optimization of tool paths to help you when you are roughing. Go back to this. Turn you back on. Oops. That's nice. So when we're roughing this part down, our original toolpath was made up of all of those toolpaths. Okay? But it was made up using, and let me turn on my tool, just that tool. Okay? Now, what the optimization is on a roughing toolpath. So if I deleted this, made a new roughing toolpath, you could then go in here to optimization and go divide toolpaths by lengths. And then you can assign, and you can pick tools, create tools on the fly, it's up to you. You can assign multiple tools. For example, this first tool, tool 1, if I hover on it, you'll see that it's my shorter, stubbier tool. Tool 2, it's got a longer reach. Tool 3, longer reach. Tool 4, longer reach. And then what happens when you click OK is it took that original roughing toolpath and it now divides it up based on what each of those tools can actually reach without colliding. Okay? So the results are that first tool is using that second tool is machining there, the third tool is machining all of that, and the fourth tool is machining all of that. Okay? So you have the ability to optimize your toolpaths. I don't believe it's limited to just roughing. You can use it on, I think, all the 3D finishings as well. So, yeah, cool. So that brings us to the end of the what's new for 3D milling. Does anybody have any specific questions? Has that been available for a while? I think it was available, but I think it was available years ago and then they took it away because it didn't work well. And I think it's been rewritten and re-released. So, okay. Any other questions? If not, the last webinar this today is going to be this afternoon at 3 o'clock Central, and we'll talk about some of the new features that are available in 4D and 5D machining. Until then, have a great afternoon, everybody.